In this first recap video on calculus, we refresh our memory on how to do integration by parts. Whenever you encounter an integral of a clear product of two functions, it can likely be solved by integration by parts. It's always worth a try anyway. The first step, and oftentimes the most difficult one, is to rewrite the product of the functions as the product of one of the two functions with the derivative of the other. Having done this, a straightforward formula can be followed to get the right result. However, it's this rewriting step that oftentimes trips students. So let's see this in action by solving two integrals. First, we are solving the integral from 0 to pi of x times the cosine of x. Clearly, we have a product of two functions. And now we need to decide which of these two functions we will write as the derivative df. Even though there is no clear rule for this, after some practice you will be able to use some foresight to pick the right one. Here we take the cosine of x dx as being df, meaning that f will be the sine of x, its integral. This leaves us with x as g and correspondingly dg as dx. I will come back later to show why the opposite choice wouldn't have helped us. With this identification, we can use our formula. The first term is simply the product of our two functions filled in at the boundaries, x times the sine of x at x is equal to 0 and pi. The second term, with a minus sign, is the integral of f, which in this case is the sine of x, times dg, which is dx here. Thus, we have now rewritten our original integral to an integral we can readily solve. If we would have taken the other choice before, the integral to solve would have been cosine of x d of x squared, unsolvable. Filling in the boundaries for this first term and calculating the integral of the sine of x and filling in its boundaries, we get our final result. The integral of x times the cosine of x between 0 and pi is simply pi minus 1. The second integral is that of the natural logarithm of x, integrated from 0 to e, Euler's number. Even though we do not have an explicit product of two functions here, we can still use integration by parts to solve this integral. In fact, it's the only way to solve it. The trick is to consider the integrand as 1 times the ln of x, with the number 1 being a constant function. Then we need to choose f and dg. Now clearly, we cannot pick the ln of x as dg, because that would mean we'd have to integrate it to get to g, which is exactly our starting problem. Therefore, we are forced to pick the ln of x as f, and thus df being 1 over x dx. dg will simply be 1 times dx, and thus g is simply x. Filling in our formula, we get the ln of x times x filled in at the boundaries, 0 and e, and minus the integral of x times 1 over x dx from 0 to e. We cancel out these x's in the integral, and we are left with a trivial integral. Computing these terms, we get the ln of e times e minus the ln of 0 times 0 minus e. Because the ln of e is simply equal to 1, we are left with e minus e, which is evidently 0. Thus, if we look at it graphically, the negative area under the curve from 0 to 1 is exactly equal to the positive area from 1 to e. And this is how you use integration by parts to solve many integrals. If you want a more elaborate video on the topic, or just want to have more practice, I have a dedicated video linked down below. And as always, I thank you for watching and I will see you in the next one.